So in this lesson, we're going to talk about parallel and perpendicular lines. And before we talk about specific characteristics, we're going to look at a couple lines first. All right, so we have the equation y equals 1 shown on our graph up here. So this line right here would be y equals 1. And in order to be parallel, if you think about streets that run parallel in a city, for example, they run this way and you're never going to get to an intersection between those two roads because they run next to each other the whole time. So if I'm going to write the equation of a line that's parallel to this one, I need to find another line that's y equals some number that's going to run the same direction as y equals 1. And just to make sure you can actually see this, this equation is y equals 1, this line right here. I know it might be hard to see. So there's y equals 1. And you could really and truly pick any line you wanted to. I'm going to pick one down here just so that there's a little distance between them. So this would be y equals -2. You could do y equals 5 or y equals -1 or y equals 0. You could do any of those equations and it would still be parallel because it's running in the same direction. Now on the flip side of that, if we look at something being perpendicular, well, parallel runs directly side to side in the same way. Here's y equals 1. Now, if we're running perpendicular, if you think about perpendicular streets in the city, if one is running this way, the other one is going to cross at a four-way stop. And it's a very specific way that those streets intersect. So this has a slope of 0. A perpendicular line is going to come this way. So they're going to meet in a very specific way, which we will talk about in just a moment. And this perpendicular line would be x equals 2. Now I could have done x equals -5 or x equals -1 or x equals 0 or x equals 3. Those would all be lines that are perpendicular because of how they are intersecting right here at this intersection point. So things about parallel lines that are important to know: they have the exact same slope, which is why they're running in the same direction with each other. The y-intercepts of these lines have to be different, and the lines are never going to intersect. So they're going to run next to each other, parallel, forever, and never cross. Conversely, perpendicular lines meet at a 90-degree angle, and the slopes are opposite reciprocals of each other. This is the most important piece here. So in order for something to meet at a 90-degree angle, in order for two lines to meet at a 90-degree angle, one slope is going to be the original fraction. The other slope has to have the fraction flipped upside down and be the opposite sign. So if the first one was positive, the second one has to be negative. So another example we could see here, if the first slope was, let's say, 1/3, the opposite reciprocal of that, well, I would flip my fraction, so it would be 3/1. I'm going to try to make this a little bit better visually. I didn't realize it was so bright. So this would be 3 over 1, or just 3. Then this one was positive, so the second one would be negative. So these two slopes, these would be perpendicular. Because the fractions are the flipped version or the reciprocals of each other, and the sign is the opposite. So the first thing we're going to do is just look at two examples of two lines, and we're going to figure out if they are parallel, if they are perpendicular, or if they are neither one. So this one here is already in slope-intercept form. So I know that my slope for the first one is 2. So if it's parallel, I'm looking for another slope of 2. If they are perpendicular, I'm looking for a slope that is negative and then 2 over 1 flipped upside down, which would be 1/2. And then neither is if this second slope is neither one of these two things. So the first thing I'm going to do is subtract 4x. So I'll have negative 2y equals negative 4x plus 8. And I'm going to divide by negative 2. So this will be y equals negative 4 divided by negative 2 is positive 2. So here is the slope that I'm looking at. It's positive 2, so I know that these are parallel. Because the lines have the same slope. I don't know why. All right, that's a little better. I don't know why it got so bright there for a second. All right. Same idea, parallel, perpendicular, or neither one. So this first one, we have a slope of 3. So I need a slope of 3 if it's parallel, or negative 1/3, because that's 3 over 1 flipped upside down, if it's perpendicular. So I'm going to subtract x from both sides and get these both into slope-intercept form. And then dividing everything by 3. So I have y equals negative x over 3 is really the same as 1/3 x. So these are perpendicular. And I would say because the slopes are opposite reciprocals. Oops. All right, now we're going to actually practice writing some equations. So they want it in slope-intercept form. So I know this needs to look like y equals mx plus b. And it's going to be parallel to this line here and go through the point negative 2, 2. So that tells me that I'm going to start with point slope form. So our point is negative 2, 2. And our slope, since we're parallel, has to be the same. So it's going to be 1/2. So I'm going to start with point slope form, which remember, x and y are the opposite of what they show up as in my point. So this is going to be y minus 2 is 1/2 times x plus 2. I'm going to wait for my computer to unfreeze again. There we go. So I'm going to distribute 1/2 first. So I'll have y minus 2 equals 1/2 x, and then half of 2 would be 1. Adding 2 to both sides gives me y equals 1/2 x plus 3. So these two lines are parallel because they have the same slope and they have a different y-intercept. So I know they're not the exact same line. Last one we're going to look at, they want us to write an equation that's perpendicular, again in slope-intercept form, and then they gave us a point. So since they gave me a point, I need the point and the slope. Well, I don't have the slope in standard form, so I'm going to have to rearrange this. Getting this into slope-intercept form. So this would be y equals 1/2 x minus 1, which does happen to be the same equation we used last time. Now, since we're doing perpendicular, I have to do the opposite reciprocal. So flipping 1/2 would be 2 over 1, which is just 2. It's positive here, so it needs to be negative here for perpendicular. Now, working towards slope-intercept form, I'm going to start with point slope. And I'm going to distribute and then add 2. So I have y equals negative 2x minus 2. And this would be the equation of my perpendicular line.